Thank you everyone for joining us. For those of you that don't know me, I think I recognize most people here, but for anyone that doesn't know me, my name is Barry Cranford. I'm the organizer of the London CTOs, and we actually have the founder, Steve Harris, as well here at the London CTOs all those years ago. I also run RecWorks, which is a recruitment company. If anyone's interested in talking about recruitment, let me know. We also do a load of other things like help with introductions to mentors, CTO mentors, and getting involved in public speaking. So anything like that at all, then feel free to come chat to me afterwards. But today we're joined with Matt and Tom from Fuzzy Labs, and today is all about MLOps. So hopefully you've all read the synopsis, so you've got a bit of an idea about what to expect. We've had a bunch of questions that have been submitted on sign up. And a few were kind of some overview questions. So we're going to kick off. Matt's done a few slides as a bit of an introduction to the subject. So we're going to kick off with 5 or 10 minutes from Matt speaking about it. And then after that, we'll go to just general questions. I've got some questions this end, but I'm far happier if anyone on the call just wants to submit things and mention things on the chat or reach out and ask anything. So we'll keep it organic, we'll keep it informal, and we'll see how we get on. So without further ado, Matt, I'll hand over to yourself.
Thanks, Barry. So let me just share the screen. There we go. So the question everybody asks at the beginning of the presentation, can you all see my screen? Can you all see the slides? Is that a yes? Can anyone not see anything?
Yeah, got it, mate. Yeah, we've got it.
Excellent. All right, so yeah, the slides I'm going to show you, I'm not going to go through all of them because after all, this is a roundtable event. You don't really want to listen to me talk at you for 30 minutes. These are some slides we put together for a similar talk we did a little while ago. I'm going to show the first half of these slides, which is really setting the scene for why MLOps is a thing. Why should we care about it at all? Why does it exist? Why are people talking about it? And then I think after that, it would be good to discuss how the specific kinds of problems that people have encountered in real life and how we can approach them. And that way it can be a much more open discussion rather than pure presentation. So why is everyone talking about MLOps? I like to tell people that forward-thinking businesses recognize the value of machine learning but struggle to execute. It's a very nice phrase because it makes people feel good. They think, oh yes, I'm a forward-thinking business. I recognize the value of machine learning. But yeah, actually, I am struggling to execute. So it's a nice way to introduce it. When we get statistics like 90% of AI and ML projects fail to make it to production, as you start to read about MLOps on the internet, you will see numbers like this, usually not backed up by any serious science, but at least by anecdotes. I like to joke that every time someone does a talk on MLOps, this number goes up. But then for maybe something a bit more concrete, Google, when they launched their Vertex AI platform recently, they start out in the announcement for the platform, they say machine learning in the enterprise is in crisis. And this is Google, who also started off a lot of MLOps. They did a lot of the initial research. There was a couple of papers, the technical debt, the high interest credit card of machine learning, that paper, and another one that Google published that started all of this off. So the point is that companies are investing in machine learning, they're investing in data science, but they're not getting value out of it. So I think, as we know, a typical project, we start with a complex problem, a problem that's complex enough that we're not just going to solve it by writing some simple logic. We need to use some data, train a model, learn from those patterns, build something that's adapted to the data that can be adapted again in the future. If it's not that kind of problem, if it doesn't have that kind of complexity, then we're probably not using machine learning in the first place. So then we're going to gather some data, we're going to do some experiments, and ultimately we're going to build a model. And for that model to be useful to the business, we need to deploy it into production. We need to see actual results from that model. And then there's the XKCD. I suspect you've all probably seen this one, right? The giant pile of linear algebra which you stir until you get the right answer. So the issue is that model is 1% of the solution. This is the second made up statistic in this presentation, by the way. So as for MLOps, it's a modern approach to machine learning that aims to reduce the pain in productionizing models so that you can get the most value out of machine learning as quickly as possible while reducing risk. It's the current trendy thing. As Barry intimated earlier, everybody's talking about this thing now, and there's some hype around it, and perhaps, as there is when you've got hype around something, perhaps a little bit of undue hype, but then also I think some serious benefit in there too. So this is the Google Trends interest for MLOps over time, and we can see like 2019, since 2019, it's really shot up in interest. So I'm going to go through 4 high-level ways that machine learning projects can go wrong in our experience. And then I'm going to stop the presentation, and I think then it's probably a good opportunity for us to enter into some discussion. So the first syndrome, so to speak, is this failure to collaborate. So it's the same as when we're developing any kind of software, right? We need to be able to ensure that a team of people can work on a common code base, and that we can track the history of that code base, that everybody can see that history, get to a certain point in that history, contribute in a meaningful way. We want to make sure that one person isn't waiting for somebody else to do something before they can do their work. So we need tools that allow us to track not just the source code, but also the data, because data can change over time as our understanding of that data changes. And to track the experiments. So by experiment, I really mean, I don't know, I've been tasked with training a model that can look at a photograph of some products on a shelf and identify the brands behind those products. So that's my task. The first thing I'm going to do as a data scientist, if I put my data scientist hat on, is say, okay, I have a hypothesis about how to do this. I reckon that if I train the model in this way, and the data looks like this, then I'll be able to get a decent result from this. So the first thing I'm going to do is an experiment. I'm going to try that theory out, and I'm going to iterate a few times before I've got something that's even approaching something that we might want to deploy into production. The thing is that if you have a team of people doing these experiments, then you really want to track those experiments over time, because, suppose I say, oh, right, I've got 90% today. And suppose it's Friday and I'm going on holiday next week. I've got 90% accuracy on my model. I'm very happy about that. I go around to all my colleagues, I brag about it. I say, oh no, brilliant. Look at me, I've done 90% accuracy. Bye-bye, I'm going on holiday. Well, that's all very well and good, but now the rest of my colleagues need to say next week, oh, well, how on earth did Matt do that thing? And you know what, if we've got experiment tracking, if we've got a way to track that history, they can look back at it and they might well find, oh, actually, yeah, there's 90% accuracy, but I've had a look at this experiment and there's something wrong with it. So, Matt should maybe calm down a little bit on the bragging there. So this kind of thing enables us to collaborate effectively and get things done quickly and efficiently. And then the second issue is a loss of knowledge. So maybe I go on holiday and I don't come back. So this is kind of related to the first issue, right? It's, look, if we don't have a central place where we're tracking source code, data, experiments, and the outcomes of those experiments, then what happens if somebody who has key knowledge leaves the team? What happens if we want to grow the team very quickly, and now our top data scientists who have all the knowledge are having to spend all of their time explaining everything to the new people who've joined the team, and various details get left out and so on. We know these kinds of problems, right? Because these are the issues that we get in any kind of software development. Ultimately, it's about repeatability. It's about being able to say, I can look at a central place where all of this knowledge is represented, I can pull it down and I can repeat it. Then we have failures in production. So this is really about monitoring. It's about knowing I've deployed my model to production, I've been successful, but does it continue to function correctly? Are there some edge cases we've missed that perhaps cause a service to crash or cause it to give incorrect results? And if so, how will I know about that? And if it does go wrong and I do know about it, how do I fix it? Can I quickly roll back to a previous release and deploy it? Do I have proper CI/CD in place that would allow me to do that? Because we need all of that for machine learning models, just as we have for any other kind of software. And then we have this regulatory and ethical risk, which I think is a very interesting area that's often forgotten in these discussions from what I've seen. So my favorite example to give for this, and forgive me if you've all heard this example before, a couple of years ago, Amazon wanted to streamline their hiring process. So they trained a model which would screen CVs, and then based on that, they could decide who goes to interview and who doesn't. It was all very well and good. The trouble is they had trained the model on their existing CVs, which happened to have a substantial bias towards males, because that was the workforce at the time in Amazon in technology. So therefore, the model also showed a bias towards males against females. Now, this kind of thing, when it happens, I mean, this was Amazon's internal experiment. The impact on Amazon in terms of reputation wasn't huge. I can come up with, there are other examples where reputational impact has been more significant. So there's lots of stories like this out there. But the point is that if we're not thinking about, when we train this model, are there biases in the data? Are there things here that are going to cause us a serious damage to the reputation of the business in the future? Even worse, are there things in here which would cause regulatory risks? So are we going to be fined for decisions we're making about, for example, lending applications because we didn't do enough due diligence on this model, or because we can't explain why this model gives a certain result? So yeah, I mean, that concludes the 4 things, and then we can stop on MLOps to the rescue. And yeah, so that, Barry, I'll hand back to you to lead the Q&A, and then
yeah, fantastic.
Go from there.
Thanks very much, Matt, for that overview. So does anyone have any initial questions, any burning questions from what Matt was saying there? Either raise your hand, just unmute your mic and come on if anyone's got anything to kick off from what Matt was saying there. Yeah, Alex.
Hi, Matt. Sorry if I'm jumping in too quickly, but how much is it is MLOps software, and how much is it kind of like business management and management of people and processes and stuff like that?
Yeah, that's a really interesting question. I think also there's something I missed out on, which maybe we can get to in a second. I'd be curious to do a bit of polling to see who is doing machine learning in what capacity, and what, yeah. But to answer the question first, I think, and this is my opinion, my take on it.
Figure in the air.
Yeah. I mean, I think it is very similar to the effect that DevOps had on the software engineering industry 10, 15 years ago, in that it's a combination of, there's a bunch of tools out there and those tools are getting better and better. You can take your pick from those tools. Almost doesn't really matter which tools you pick as long as the team agrees on it. But then there's also a culture to it. There's a mindset, and that mindset isn't a pick and choose thing. It's, you have to write your code and in a way that's ready to be deployed. You can't say it works on my machine and it's someone else's problem to deploy it. You have to adopt that mindset. So I think there is a broad mindset that an organization has to adopt in addition to the tooling. I think it's 50-50 to pick some numbers out of the air.
Thanks very much. Yeah, can't argue with that, really.
I mean, Barry, what's the best way to do some polling?
We can set up a poll. We can do that on Zoom. Matt or Tom, if you want to follow me across the exact question to ask and the options there, I can do that. While I'm doing that, Greg's hands up. Do you want to, Greg, do you want to come forward with your question, and I'll figure out the poll in the background?
Sure. Hi. I have a very practical question, I guess. And this is, I mean, potentially for Matt, but I would welcome responses from others as well. Are your data scientists, machine learning engineers, whatever their titles may be, the people building the models on your team, are they doing all of their work in Jupyter notebooks? And if yes, how are you handling version control? And if no, what are you using instead?
I'm also really interested to hear what people are doing. I mean, for us, we don't build all our models in Jupyter. We try to avoid that, and that's how we version control. We don't use Jupyter. But I mean, does anyone else have a take on that? Because I'm interested too in that one.
Well, I can talk about my experience. So the problem that I usually had in Tesco is that we had data engineering, that was me. So I'm proficient in all the CI/CD stuff and everything. But the standard data scientist builds on his own laptop. And then when it works, he asks us, okay, can you deploy this on the 600 machines Hadoop cluster, for example? And that doesn't work. So my problem usually was educational. So with all due respect to data scientists, great people, but they're usually not great developers because they don't have the practices like version control. What is it? Most of them weren't even using Git. They were putting things on the nodes. So the main problem is find a structure that enable them to put their abilities to the service of everybody and of the company. And that was the main problem that we tried to address when I was there, building a set of tools that, and maybe that's MLOps, I don't know. But yeah, basically giving them a way to deploy a model in production with a system, a repeatable way in a system. Then, having the ability to put things in source control and version them. And yes, the Jupyter Notebooks is a great example. So yeah, here's my model is in this notebook. Say, what? Sorry, how do you want to run this on this gigantic cluster? So there is this dissonance that maybe MLOps is for, but you tell me, I'm not the expert here. That's what we were trying to do when I was there.
Yeah. So you're in a position of trying to productionize what the data scientists are producing. Now, I suppose if they hand you something, then even if it's nicely packaged and you put it in there, they're not versioning it on their side, are they? So if they
there are multiple problems, not version on their side, and then what you get is always different. You never get the same thing. Sometimes it's not, sometimes it's some kind of model written directly in Python with pieces in Scala that somebody else wrote. So it's just very confusing. So we needed a way, a framework, so that we can, data scientists put something at the start of the pipeline, and then it goes all the way through. You get you get you get the macinated. I don't know the English word. Sorry. It gets transformed, and then finally it arrives maybe on a development environment. I won't put that in production. So we usually restrict a set of nodes for that. And then eventually, when it passes all the checks, it goes to production. Yes.
Do you think that it's a case of, look, we need a magic bullet tool that you can hand the data scientists that they will use, or do you think that, do you think it's actually data scientists need to learn Git, they need to learn DVC and these things?
I mean, they definitely, I mean, in my view, they definitely need to learn. They're writing code, so they need to know how code works. And we reach this level of sophistication in software, in code management after years and years. Come on, I mean, they need to do basic things like using version control, understanding what a branch is, understanding what a commit is. If you're using Git, if you're using SVN, the same, but they need to understand what SVN is, how it works, and the perks of it. They understand, yes, version control, and they need to understand the basics. I mean, and of course, when you write a model on your laptop, it doesn't necessarily scale on on a cluster. So they also need to have some basic understanding of distributed programming at some point. No? Yeah, I mean, the problem is that we didn't have, they didn't have the education, and our fault was not to provide them enough education to a point. And also we weren't providing tools that have less friction, because many tools have a lot of friction and they're difficult to use. And yeah, it's like in software development. So you don't want to be, I mean, of course you can be a developer that knows perfectly Kubernetes and everything. You can deploy just like that, but usually you don't. So normal developers know they maybe run a micro Kubernetes on their own machine, and that's it. They don't know the complexity of a production setup, and that's okay, because we have DevOps for that.
Yeah, but then I would think, I don't think it's even necessary to have Kubernetes running on your machine, for instance. It seems like what's necessary is that the model is packaged in a way that the same thing can run on my machine as can run in Kubernetes. I don't need to care that it runs in Kubernetes, as long as it's containerized, as long as it's in some standard form, right?
Yeah, I fully agree.
Matt, I can see Steve's got his hand up. Do you want me to do this poll quickly first, and then Steve bring you in for the question?
Yeah.
Is that right?
Yeah. Okay. Sure. Yeah. Well, let's see. We'll start off with, I'm keen to know how many people are currently running models in a production environment. Oh, right, you've done. Yeah.
We did it in the background.
Okay,
Matt.
cool. Yep. We did it in the background. Fine. Then I'll shut up.
Of course, there's always somebody who actually wants another option that's not on the list of the poll.
What should we add, Alex?
I work with several companies, so some of them are any of all of these options, really.
Sorry, I forgot the other.
Yeah.
It's the problem with a group of techies. There's always another answer.
The edge case. Matt, is that what you'd expect? That split?
Yeah. Well, is it what I'd expect? I don't really know what I expected, to be honest. I think there's more I'm all with MLOps answers than I expected, actually. It's making a huge difference to our ability to get value out of ML. Okay. I mean, it'd be interesting to hear from the people who gave that answer if they're happy to say why it's making a difference. I think that could be interesting to explore.
It's interesting from our point of view, because we're a new startup 2 years in, and we've spoke to customers who are all spectrums of this, like people that don't know what AI is, and we go in and do a pitch on what's machine learning, how to recognize cats from dogs, to people that want to try a model, and we've built experimental models for them, and then but to sort of prove the concept and the value, through to people that actually they're fully bought in, and they want an efficient workflow, and they want a Google or Uber type machine learning pipeline in their organization. So but we're seeing a big shift in this in MLOps, and the gap between data science skills and then being able to deploy those models into production, understanding cloud technology and DevOps and that kind of thing.
Yeah. Should we do should we get to Steve's question? I know Steve's been waiting a while. Had your hand up for a while.
Absolutely, yes, Steve.
Yes, I just wanted to say, so we're an ML company, and I'm one of the people that said we're all in with MLOps. I was just going to make the point that I would never hire ML engineers. I'm not going to use the term data scientists because I think it's unhelpful, but ML engineers that aren't all in for containerization, like particularly with the modern frameworks like TensorFlow and PyTorch, getting them to play nicely with the operating system is so difficult. If you can't containerize your code, it's never going to run anywhere other than your desktop machine. So I wouldn't even consider hiring someone that didn't have that combination of skills. There's enough people out there now who are good at machine learning and also have an engineering background that there's no reason to hire the people that were floating around 10 years ago who've got a PhD but can't write code. They're just dangerous, frankly. But yeah, so because our core product is ML based, we've always had like to operationalize the ML. I've never used the term MLOps. I kind of picked that option because it was the closest to where we are. Like, we have no issues with how it is to operationalize ML, but that's because we do so much of it. We've got really good at it, but it's not a formalized department or anything. It's just part of the DevOps environment, and the ops team manage it. And so we do everything through Docker and Kubernetes, but could equally be any other containerized platform. But it's absolutely got to be containerized, otherwise it's just never going to work.
So you're saying you were doing an MLOps since before it was cool?
Well, I'm not sure if I'm doing MLOps or not, but we have operationalized ML, and it's fairly frictionless. So I guess by definition we are. But
and Steve, can I ask, where do you see the gaps in the tooling at the moment for MLOps, or whatever we call it?
I don't honestly think I do. I think the gaps are more in the sort of ops systems. So things like Kubernetes. I mean, so Kubernetes is fantastic, but it's we actually migrated recently from Docker Swarm to Kubernetes, and it was a complete nightmare. Kubernetes is so complicated. Only a handful of my engineering team understand it, and I've got 2 ops guys who understand it, and it's just so complicated. For unless you're running like an organization with 12 data centers spread across the planet, it's total overkill. So there just needs to be some sort of like, a Docker Swarm's dying. A Docker Swarm was really easy, but it's not being maintained anymore. It's really buggy. So there just needs to be some mid-ground between the non-existent now Docker Swarm, and everyone's doing Kubernetes, but it's overkill for so many systems. But the ML side of it works completely fine. There's a bit of extra complexity around the hardware. Our system like switches between hardware accelerated Amazon instances and regular CPU based ones based on cost. So that adds a bit of extra complexity, but other than that, it's pretty straightforward. It's more the containerizing platforms that add the complexity. Probably there's some skew there because I come from an ML background. I was an academic many years ago, and I happen to do a lot of ML stuff back in the day. So I regard that stuff to be easy and everything else to be difficult. From a personal perspective, I don't think most teams see it quite that way. But yeah, I don't think so. That's a very long-winded way of saying I think there's nothing at all wrong with the ML tool chain in general. We even in one case deployed IPython notebooks on top of a system called Voila, I think, just as like a beta thing for users to try out. It was fine. It's not really, there's no real challenges there. We obviously wouldn't do anything production off of IPython, but for small things you can.
I mean, what's your take on these packaged platforms like Google's Vertex or Amazon's SageMaker?
Yeah, we've used SageMaker a bit. It does save a lot of time because you get an environment already running up with like TensorFlow or PyTorch or whatever pre-installed. But But then you're locked into, that's why I mentioned our systems flip between CPU and GPU, because the SageMaker platforms, I believe, is only available for NVIDIA accelerated hardware, and we don't 100% run on that. So we don't tend to use it that much. We only use it for things that always run on GPU. But it does definitely makes things easy. And the SageMaker, I forgot what it's called now, the SageMaker IPython instances are super handy for just trying things out.
Yeah.
Although you can run up some quite frightening bills. But yeah.
They're expensive. Yeah, the hosted notebooks. Yeah.
The problem is it's easy to forget to shut them down, and the clock keeps ticking. But in terms of actually the operational side, yeah, it's good. I mean, if you're in a platform where you're 100% GPU, then things like SageMaker are brilliant. I've never used Google's thing, so I don't know what it's like, but I imagine it's similar.
It's pretty raw.
Okay. Well, SageMaker's, I mean, you get everything you want, right? You get a Conda environment running all the ML libraries with compatible versions of everything, and you just off and writing code. It's super easy, as long as you're happy to only run on the SageMaker platform, which comes with some sort of dollar implications.
Yeah, I mean, Vertex, to be fair, it's the training and deployment bit is good, but it's like the rebrand of Vertex was the full MLOps thing. So they put in experiment tracker, data versioning, monitoring, but they're not all there. They're sort of, they want to push the perception that they've got a full MLOps solution, so you don't necessarily go to another vendor. Like there's quite a few packaged options out there, but we did an evaluation, and there's certainly a bit of a gap, and I'm sure they'll fill it, but it's not there at the moment.
We haven't really found so Amazon's got a whole load of off-the-shelf services. So I'll shut up in a minute, let other people speak, but Amazon's got a whole load of off-the-shelf services for running like ETL processes and data pipelines and data cleansing. We found them all to be completely useless. It's probably a reflection of the domain we work in, which is quite high volume data. But for us, they didn't add any value. We ended up building our own pretty rapidly, just because of trying to squeeze the domain that our problem exists into the Amazon off-the-shelf tools just didn't really make any sense. There's kind of so many compromises and no real benefit.
Could I just, this is Joel. Could I just ask a follow-on question, actually? And Steve, even though you wanted to shut up, I just wanted you to expand on one thing. So I just want to pick up your comment earlier about data scientists without engineering skill sets, and I took that to mean like relatively advanced engineering skill sets being sort of a bit of a liability. I just wanted to get your view on, does that mean that
I think Joel's might have dropped out, unless it's me.
No, I think
no.
he has. Okay.
Just as he was getting to it.
Does that mean? That's a deep question. Does that mean?
Yeah,
tools that would need to specialize on and then work together as a team across
Who's next?
those areas?
Sorry, Joel, I think we completely lost your audio there. Are you back? No. Okay. Ed, should we go on to Ed's question then, and then we'll come back to Joel when his audio's back.
It's less of a question. I just wanted to add to Steve saying that I think sheds light on.
I think we're getting some feedback on your audio as well there.
Yeah.
Is everyone's audio okay? Can everyone hear me okay?
We can hear you okay.
Yeah.
Good. Okay. Ed, we'll come to you in a second if you want. Chris, I see your hand up there. Chris, did you have something that you wanted to add?
Yeah, hi. So my question is, what are the tools that people use or recommended kind of people processes around the whole QA testing of machine learning models? Because my background is in a prior employer, I ran a small ML project and we took it to production, and it's adding business value. So that's great, you know, fighting fraud, the machine learning. And so it was a non-core project to the company. So, you know, if it's offline, it's not the end of the world. And it was only done with one developer that I was managing. So we didn't really have any QA process. We just got the developer to manually check for regressions using a spreadsheet he was used to track it. So we completely bypassed the QA team. But I think that for companies where machine learning is absolutely the core of the company and you've kind of put more investment into it, how do you solve the tough problem that you've got these, you know, QA staff that never seen machine learning in their life, and you're basically saying, we've been changing the algorithms, and that may or may not have had an adverse impact on the model, like to lose accuracy. Can you check that for us? Do you see what I mean?
Yeah, absolutely. And I think there's two sides to it, because there's the testing that you would ordinarily do on a model while it's being trained, and then, you know, that while you're training the model itself, you're going to split your training data up. So let's start there at the very fundamental. You split your training data up into a portion of it used for training and a portion of it used to test. But that's more checking that the model is accurate. It's giving you an accuracy measurement for the training data. I think then beyond that, yes, automated tests as part of a CI/CD process, that's great, as we would for any software. But there's something beyond that that I think is important, specifically for machine learning models, because we are building something which is going to make, but by its nature, it's going to give outputs that we can't predict, we can't expect. So there needs to be ongoing monitoring. I heard of a prominent company who I won't name, but I was talking to a head of data science at a prominent company who said that, yeah, we deployed a model and it's making predictions about our customers, and we didn't realize that it always gives the same answer for every customer for about 3 months. So to not notice that is really very, very, very surprising.
I hope that wasn't a machine model like ours at my prior company, which was—
You would really hope not.
Is this, well, what I'm going to say is with the same objective, which was, is this customer a fraudster? So if the answer was always yes, that would have serious implications.
So yeah, I mean, I think it's crucial to monitor the inputs and the outputs of a model on an ongoing basis, because, okay, suppose the inputs change suddenly, they drift. You know, that could indicate a number of things. It might just indicate that customer behavior has changed, and therefore we need to gather more data because this change of behavior hasn't been represented in the original training data. So we gather more data, we'll train a new model, everything's good. It might indicate something else. It might indicate that the inputs are bad. You know, maybe whatever software is providing these inputs to the model in the first place has a problem. So that's why it's changed. And then similarly, you know, if you see the output of a model, you expect two things. You expect the distribution of outputs to match something that some baseline that you already expect. So, you know, you expect a certain amount of fraud, certain percentage. So therefore you'd expect the output of the model generally shouldn't deviate from that expected distribution. And then if it drifts, then, you know, what does that indicate? It could mean that there's an edge case that wasn't accounted for in the training data again. So again, you're going back to saying, maybe we need to retrain the model. And in some cases, you might even automatically retrain the model. So I think this is a huge, huge gap. Now, yeah, I mean, in terms of tools, there's a few things out there. There's one prominent tool is weights and biases. I haven't got a lot of experience using these tools, so I can't give opinions on which ones work best. But, you know, weights and biases is one to check out. There's a few others out there. But regardless of tool, I do think it's absolutely crucial not just to do testing at the point of training before you deploy something, but then this ongoing testing, monitoring to make sure that it continues to make sense in the future.
Yeah, and really the question I was going to is, you know, how companies do it at that big scale, because it's all very well always involving humans, involving staff, but it's so you know, kind of in vogue to say continuous deployment. So we didn't need continuous deployment, but for those that actually have taken ML to that next stage, you know, that some has anyone on this call actually done something where they have a kind of dedicated QA system testing environment? It's completely own unique machine learning just for that, and it maybe, I don't know, kills all the data in that model, then basically rebuilds a brand new model, brand new data, start from scratch, and then you've got almost a repeatable test thing. Because what I'm getting at is when you try and say, well, human checks take such a long time, can we, you know, as well as having some human checks, can we have automated checks? I appreciate you said the range. I think that's a good idea, from X percentage up to Y percentage, a sensible range. But just to have some automated checks against the thing, it sounds like that's the problem. It's just the, you know, do people have an almost dedicated system testing environment for ML, and then you could just throw it away, rebuild it, throw it, rebuild it, and then crucially add some assert logic with a unit testing framework against some of that, you know? But this is the problem, as we know, with unit tests. If it ends up being very non-deterministic and flaky, it's just a waste of time. So, yeah.
Yeah, specifically on the unit tests, I think there's a lot of room to make use of property-based testing here, because property-based testing isn't testing a fixed assertion, it's testing a condition which can be a probability distribution, and ultimately that's what we're dealing with when we're training models. I think for the wider question, yeah, I mean, maybe some other people, does anyone have that, is anyone doing monitoring at that kind of scale of a machine learning model who could weigh in there?
We're not doing it at a very big scale yet. Expectations, which is basically, I mean, it's more in the data pipeline point. So it's sort of the checking the case where maybe your inputs are going off from what your previous expectations were, or something's wrong with your pipelines in general. But it's I guess the types of tests it's allowing us to do are basically looking at the outputs of the models, if they're in the sort of, if they seem like realistic predictions, right? So if it's not doing something that, if it's predicting something that we would normally expect to be, I don't know, a numeric value that would be between 0 and 1,000, and suddenly it's predicting 10 million, that kind of like testing for those types of things is actually proving quite useful, even in the early stages that we've been using it.
Do you test that on an ongoing basis, or are these tests you run before deploying the model?
So we're right now doing it sort of manually with an eye to doing it in more of a pipeline. As I said, we're still fairly early in it, but this is one of the challenges we were looking at, was how do you test the performance of models effectively in the same way you might do with unit testing code, for example, where it is quite easy to say, I have these inputs, I know what the output should be, and so you can just write a test that sort of confirms that given inputs you get the output you expect, which is much harder to do in the model. But this is useful for us to kind of bring that same idea into our ML building and deployment.
We have some pretty significant QA challenges. So our clients are very keen on, so we train classifiers on behalf of our clients who then use them in a web app. They don't really expose to the ML guts. They just treat it like a normal web application. The issue for us is not so much the ML models changing, because we freeze them inside Docker images, because one of the requirements our clients have is that they deliver consistent results. So when they're trained, we freeze the model with the current generation of the classifier tech and just shove it in an S3 bucket or something like that. The issue we have is the underlying data shifting. So to give a bit of context, we're classifying patents, and obviously the terminology and the technology that's being patented shifts over time. So we've got clients who are monitoring patents in the LiDAR space, for example, but people are coming up with new ways of making LiDAR. So the patents that are being filed this year don't look like the ones that have been filed 3 years ago. So we have to kind of stay on top of that. And we haven't found any way of automating that. It's ridiculously manual. We've got maybe 10,000 live active deployed models, and we just have a team of people that monitor them. But one thing we did do is we built some features into the application which the users like using, which cause the users to notice when there's things that we're missing, or things that are just falling out of the classifier that they find interesting. And there's kind of like alerting that the user's spotting things that are just outside the threshold of the classifier. And that saves an enormous amount of effort, but at the end of the day, it's just a hugely laborious task. We have built a whole UI for doing QA that mostly used by our internal team, not by our clients, which speeds things up massively compared to doing it by hand. But it is just a huge amount of effort. We just charge for it. It's another thing that adds to our defensive moat and adds to the cost of delivering the product. But at the end of the day, as long as it's economically sensible, it's fine. But it is definitely an enormous challenge.
Yeah, thank you.
I don't think it's possible to automate it. I can't imagine how you would for our particular problem of the domain shifting rather than the model shifting.
Yeah, that's great. I think that's great to hear that. Thank you, Steve, because me as a relative, amateur in machine learning in my prior company, when I introduced it to detect product fraud, obviously with only I only wanted to put one developer on it because it was treated as a non-core project. I thought, what do big companies do? What do people that have this at the core, what are they doing? And I think you've just confirmed that it is genuinely a difficult problem to solve, really.
Yeah, and one of the paradoxical things about ML tech is it's ridiculously labor intensive. Like building the models, optimizing the models, building the training sets, it all requires manual effort, like way more than actually just writing code, which is kind of a bit peculiar in a way. But it's all down to does the economic benefit of building the ML models, does it deliver value in the product? That's the only question, really.
One thing I'm curious. Go ahead. No, please.
Can you hear me all right this time? I think earlier it was okay. Fine. I was going to jump in and say, so I work at Selden, a tooling company. So one of the things we've seen from our customers, again, that issue, right, comes up a lot, is testing models. One of the approaches we've taken to that is to do like progressive rollouts of new models and with some sort of reward metric as part of that. So you can kind of say, here's my model, maybe I want to deploy that in like an A/B test or a canary or whatever, but add some reward feature to it. So whether that's user engagement or accuracy or whatever. And then you can add automated promotion at the end of it. So like, let's say you want to roll a new model out, but it has to hit a whole load of metrics, right? And that's definitely something we're seeing from like the biggest customers we have who use, models at like, thousands of models at scale, is that they can't do manual promotion of models. They need it to be automated against metrics. So that's kind of the way that they do testing at scale, at least.
Why do you say it can't be done? So, I mean, it's probably domain specific, but I mean, we have tens of thousands of models and they're all released manually.
Yeah,
so
I mean,
manually, someone clicks a button, it's literally like one click to promote to production, but it's
it certainly can be, right? But it's probably labor intensive, right? And it
Sure.
requires an understanding of the model underneath as well, which I think maybe in your scenario, your team are quite well aligned, but I think at some enterprises, it may be different, a DevOps team who are promoting things to production versus a, data science team who are actually building the models that then get handed over the fence. And that's where it's more difficult for for a DevOps engineer to say, can I promote this to production? I don't necessarily know that.
I think our situation's a bit unusual. So my ML engineering team builds tools and we have a a separate team of domain experts who do the training and the QA. So the people that are releasing the models, training them and QAing them, know absolutely nothing about ML tech. We just train them how to use the tools we've built, and they know their domain. So we've got like biochemists and physicists and whatever else, and they're doing all the training and analysis, but without ever touching any Python. But I think that's pretty unusual. And it was necessary for us to build that kind of tooling just because of the scale of the number of models we've got, and the fact that they all have to be QA'd manually. It was not just not cost effective to do that with data scientists. No one would ever pay the bill.
Yeah.
Ed, can I ask, because I've looked at Selden and we've not actually tried it out. It looks a really interesting product. How do you view it amongst some of the other competing products in the marketplace? Because you've got an open source element to it as well, haven't you?
Yeah, we have. And actually, it's a really good question to ask me now, because I'm only a month into the job, right? So I have a pretty kind of agnostic view of the tooling. And it's very much, so actually, you know, we talked about SageMaker and Vertex earlier. They're a really good example of something I think maybe works well for a small data science team or like a mid-sized company who want to be able to do like production ML, but don't necessarily have the complex infrastructure that typically, you know, the customers who would use something like Selden, whether, you know, open source or the enterprise offering do. You know, we tend to fill that gap in the market where we, you know, as a large bank, let's say, you already have a complex Kubernetes environment with loads of tooling around that. Something like Selden Core, the open source offering, because it's so tightly coupled into Kubernetes and it allows you to integrate with all of the cloud native stack, that then becomes really important for them, because they don't want to just go and adopt, you know, the Vertex way of doing things, because it then, you know, breaks people out of their fully integrated platform that they've built, you know, possibly on-prem as well. Does that make sense?
Yeah, definitely. So what's the typical Selden customer look like? It's bigger organizations, more advanced organizations.
Typically, yeah, for sure. But I think as well, we've done a good job of like promoting ourselves and raising awareness in the DevOps space, but nowhere near a good enough job of like machine learning engineers or data scientists understanding what the product is or how to use it. And I think Steve said this earlier, you know, as a data scientist shouldn't need to know about Kubernetes, right? And we don't make that easy enough for them at all at the moment. So that's typically, where our customer base lies. It's like they're cloud native ready and they're doing that at scale. And now they need to add like machine learning capability to that, rather than the other way around. So, you know, doing machine learning well, but we want to try and do scaling and cloud native deployments. We need to work on that side of things and handhold people and abstract them from Kubernetes more.
Ed, I've got a very quick question about that, if I can.
Sure. Yeah.
I mean, the data scientists still need to know about distributed algorithms, but I appreciate that they don't have to know about the particular technique for doing that distributedness. Mm-hmm. Does that make sense? Is that is that what you're saying? Or
yeah, I think probably what I'm saying is actually more like low-lying concepts. Like there's no reason a data scientist should need to know what a pod or a replica set is, right? Because those are Kubernetes concepts. In fact, they shouldn't even really need to know what Kubernetes is.
Mm. It's just a way of running their code on lots of machines.
Correct. Yeah.
Yeah, I just wanted to, that was related to my question earlier when the internet dropped out, but I wanted to bring that back to like Steve's earlier comment, which I thought was interesting around like everyone should be machine learning engineers, if I'm not sort of misrepresenting that comment, Steve. And the question around deeper specialization of data science specific skill sets and more engineering related skill sets in a machine learning context. And so does it still make I would think it still makes sense to have data scientists who are deeply specialized in certain data science related topics, but have a basic level of understanding around engineering. But you have specialists also who have much deeper skill sets in certain engineering related contexts.
Yeah, so my point was that I wouldn't hire, as a data scientist myself back in many years ago, I wouldn't hire someone that was a pure data scientist, because I think they're more of a risk than they are a benefit. But that's not necessarily, but that's probably depends largely on your environment. If you're in an environment where you've got one ML algorithm and it's quite specialized and you update it very slowly, then it's probably not too big of a problem. You just need a team of engineers around them who can productionize that code. But it's not, it wouldn't make me comfortable, because you end up where no one person actually understands the whole system. So for me personally, I would only hire ML people who have both engineering and ML skills. They don't need huge amounts of engineering skills, but just being able to write code that other people can write, which I can't, for example, but and being able to bundle their code into a Docker container and how to run tests and do logging and all those kinds of things. If you can't do that stuff, you're just a bit of a liability, really.
Yeah. So
yeah.
Is it not?
We're not talking like advanced, like you know, kind of hardcore architecture skills. Just the basics of how not to shit the bed, to put it parochially.
Yeah. So it's not. So is it not that you're really only looking for like sort of core engineering profiles that have added on data science on top of that? Because I would have thought that would be a problem, right, in terms of the depth of the data science understanding.
Well, that depends on the complexity. I mean, so many things now are actually really easy. Every single year, things get easier and easier, right? So it used to be that I was hiring people that had an ML background who'd done enough work outside of academia that they weren't dangerous. Now there's plenty of engineers who've done a bit of ML either in their spare time or as a side, you know, sort of as a non-core project at work or whatever, and they're good enough. It depends on the kind of project you're trying to solve. If it's something like text classification using transformer models, like someone can learn that in a couple of weeks, right? It's just not, if you're really pushing the boundaries, it's a bit different. And you need someone that's got hardcore maths and knows all the like complicated linear algebra, but there's so few of those problems left now.
Guys, I'm just looking at the time, seeing that we're just closing in. In fact, that's just hit 2 o'clock. So thank you everyone for joining us. I'm quite happy, by the way, you've obviously got the Slack group, so you can just join in there and keep it going. I've added a link on there as well that you should be able to see if you want to share your LinkedIn details with everyone on the call. Then you can connect with anyone as you like. There's also links on there to sign up to the Slack group if you're not a member. And to follow the YouTube channel and the LinkedIn company, again, if you're interested. Tom, did you want to say a few things just in closing on the event?
Yeah, well, I'd just like to say thanks for having us. A Manchester-based startup on London CTOs. It's our first appearance, and it's been a great, very engaging debate. I think I mean, we didn't know what to expect, really. We didn't know what level people would be at, so it's been I think really insightful and a good level of detail. And if anybody wants to get in touch with either Matt or myself, fuzzylabs.ai is our website, and yeah, we'd love to chat a bit more about this kind of stuff. So stay in touch, and thanks for having us.
Brilliant. Thank you all. Thank you, everyone. If you want to hear more, if you want to go into greater depth in anything that you've heard here, like a lot of the reason that we do these roundtables is to try and see if there's anything there that would be any specific thing that we can go and drill a bit more deeper into. So if you'd like anything, either panel event on a subject or presentation from Matt or Tom, or anything in particular in any more detail, then just whack it on the LinkedIn, on the Google Doc, or just let me know directly. But other than that, thank you once again, Matt and Tom. Thanks to everyone else for being here, and we'll see you next time. Cheers, guys.
Thank you.
Thanks a lot.
Thanks, guys.
Thanks.
Yeah.